Hello everyone, my name is Courtney Lockett and I am making this video as an assignment for my teaching mathematics class. In this video, I will be discussing 5 articles and 3 key points and quotes that stood out to me within each article. In addition to these points, I will be including my personal thoughts and reflections, so let's get to it. The first article was Never Say Anything a Kid Can Say by Stephen Reinhardt. One who gets students to explain things so well that they can be understood. When I read this quote, it showed me that students can learn not only from their teachers, but from themselves. By asking them questions and having them ask questions as well, it helps them become independent thinkers and learners, which leads me to my next quote. For them to become better thinkers, they need to investigate the many possible ways of thinking about a problem. Although it's important to be an independent thinker, group work and discussions are also essential for students to learn. By listening and understanding different points of view, it helps broaden the mind and perspective on certain matters. The last quote that really struck me was, "Never carry a pencil." I never thought anything of this until I read this section, but I realized that I had a bad habit of carrying a pencil or using someone's pencil when I thought I was helping them, but really I was thinking for them. And I'm usually the person that can show you better than I can tell you, but that's not going to help our students strive if we're always going to do things for them when they need to learn how to do for themselves. So from now on is walking around with no pencil with my hands behind my back. The next article was titled A Mathematical Cornucopia of Pumpkins by Glenn Gibbard. My first quote said that connecting measuring activities with data analysis allows students to address the natural connections between mathematics and scientific activities. And I also connected it to another quote that described it as a spirit of wonder and inquiry. Math and science alone was difficult for me to understand, so the thought of putting them together was mortifying. But after reading this quote and the procedure that followed, I saw how you can bring math alive with science. The National Council of Teachers and Mathematics Algebra Standard asks students to represent, analyze, and generalize a variety of patterns with tables and graphs. I'm always focused on solving a problem, but it never crossed my mind how valuable a diagram can be in helping me to do so. I just always thought it was something to show after you work out the problem, but it's really for your benefit in using it to help yourself. I found a quote that previous knowledge and skills have been developed in part through the use of these activities to be very important. Every time you're learning something new, you think you have to learn a whole new set of information, but really you get to apply what you already know while acquiring new knowledge and skills. My third article was titled 10 Practical Tips for Making Fractions Come Alive and Make Sense by Doug Clark, Ann Roche, and Annie Mitchell. The quote that fractions are difficult to teach and learn, but they should not be viewed as a lost cause, made me feel guilty. I must admit, I gave up on fractions a long time ago once I've gotten through specific tests, but as I came across my next quote, I understood why I gave up on it. Karen identified several different interpretations of rational numbers. So there you have it, folks. It's several different interpretations, and I was never made aware of them as I was being taught about fractions. There's ratio, operator, quotient, also known as division, part, whole, and measure. As the article listed them, it was also broken down for readers to understand, and I really appreciate that, and I think anyone can learn something new from this article. Out of the 10 tips, number 9 said that take the opportunity to interview several students one-on-one on the kinds of tasks discussed in this article to gain awareness of their thinking and strategies. This tip was the one that jumped out to me because I never experienced it before. Not once in my math career has any teacher or instructor interviewed me or asked me what I thought about fractions, but I believe that probably would have changed my feelings towards fractions and not give up on it. Article 4 was titled Unpacking Word Problems for Diverse Learners, a guide to using schemas by Elizabeth Stevens and Sarah Powell. The first quote stated that students must approach word problems flexibly. There are various problem types and no one-size-fits-all strategy. I agree with this quote because all problems are different. If you try to use the same method to solve problems and it doesn't work, then you will get frustrated and give up. So you have to approach each problem with an open mind that it can be multiple ways to solve it. Teachers and students need instructional strategies or approaches that make teaching and learning word problems less formable. I also second this motion because my past teachers present the word problem as it is, but doesn't break it down for us and leaves it to us to figure out. So if you can break it down, by all means do so. You can have the better understanding of the problem. My last quote said that efficient problem solving also requires students to be analytical. Students try to find keywords or hints to figure out what to do to solve the problem, but end up missing the big picture because it's more to a word problem than you think. Which leads me to my last article, which is titled 13 Rules That Expire by Karen Sharp, Sarah Blush, and Barbara Daughtry. The opening quote states that overgeneralizing commonly accepted strategies, using imprecise vocabulary, and relying on tips and tricks that do not promote conceptual mathematical understanding later in students' math careers. This was an instant attention grabber because it was straightforward and made me want to learn what was true and false in the world of mathematics. But reducing the meaning of an entire problem is a simple scan for keywords has inherent challenges. Just as I talked about in Article 4, you will miss the big picture of the problem if you only skim for words and hints. Plus, not all the vocabulary is reliable because the word may mean one thing, but the problem is telling you another. But teachers can be contradicting when they say read carefully, but still give us a list of keywords to look out for. My last quote states that the order is not as strict as students believe. I learned that the order of operations can be confusing, especially with the different mnemonics. It may be appropriate for one problem, but work different for another problem. So that goes back to approaching each problem with an open mind that it can be solved in multiple ways. So this concludes my article debrief. At first, I wasn't thrilled about reading articles, especially about math, but in the end, I learned how to teach and comprehend math from a different perspective, which is very essential as a teacher. Thank you for watching, and I hope this video finds you well.